So here is Kramer's rule. If you are given a system of 2, so this is a system of 2, and you can do this with a system of 3, a system of 4. We're only going to work with systems of 2 for this class, but you could, once you get into this and you start getting practice with it, you could look up how to do systems of 3, systems of 4, how to find the determinant of systems that involve more than just 2 variables. Anyway, here we go. So you've got this system and we want to solve it. So the determinant is going to equal A, B, C, D. So the determinant is made up of the coefficients of x in column 1 and the coefficients of y in column 2. Cross multiply, subtract those 2 values, and you get your determinant. Now the determinant for x is given up here. You're going to take that determinant of x and you're going to divide it by the determinant. Now the determinant of x, if we're looking for the determinant of x, the determinant of x is equal to the constants. So we're looking for the determinant of x, so we're going to take the coefficients of x out and we put the constants in. And then we've got the coefficients of y, they stay. And the determinant of y, the coefficients of x stay, that's in column 1. And what do we replace the coefficients of y with? The constants. So when I say constants, I'm talking about s and t. Okay. X is going to equal the determinant of x divided by the determinant, and y is going to equal the determinant of y divided by the determinant. This seems very confusing, I'm sure. I'm sure it seems very confusing, but it's simple. Trust me. Here we go. First step is find the determinant of x, and the determinant of y. So the determinant is equal to coefficients of x in column 1, coefficients of y in column 2. 3 minus negative 12 is 15. I'm actually going to move this down here, move this down here, and that's going to be the determinant. The determinant of x, we'll use a different color. Remember, determinant of x, the coefficients of x get replaced with the constants. Coefficients of y stay. And that determinant is equal to 4 minus negative 26, which is 30. So the determinant of x is 30. Then we have the determinant of y. Since we're finding y, the constants are going to take the column, which normally represents the coefficients of y, but the x is going to remain. So the coefficients of x remain. 39 minus 24 is 15, and that's the determinant of y. Now what does x equal? X equals 30 over 15. Every once in a while it does this, it gets a little bit touchy, so we just go back out, we come back in. 30 over 15, which is 2. And y is equal to the determinant of y, which was 15, over the overall determinant, which was 15, which is 1. So our answer is 2, 1. And that is Kramer's rule. That is Kramer's rule. So let's try Kramer's rule on another problem. So you get to see my background that I love here. We have x minus 2y equals 2. 3x minus 5y equals 9. You just got to really do this a couple of times and you're good. Okay, the determinant is going to equal, see, we've got 1, 3, negative 2, negative 5, right? 1, 3, negative 2, negative 5. Why I wrote it up there, I don't know. And that's equal to negative 5 minus negative 6, which is 1. The determinant of x, look at how easy this is. The determinant of x, coefficients of x are replaced with the constants. Coefficients of y are column 2. That's negative 10 minus negative 18, which is 8. The determinant of y, the x column stays 1 and 3, but now the y's are replaced by the constants. And we get 9 minus 6, which is 3. So x is equal to, remember, dx over d, which is 8 over 1, which is 8. And y is equal to dy over d, which is 3 over 1, which is 3. So our answer is 8, 3. And that is solving systems using Kramer's rule. Using Kramer's rule. Okay, you want to try one? You want to try one? You can take any system of 2 and you can try one. So if you go back to your notes and you find a system of 2 or in your homework, I'd say go to the homework and try doing some of those problems right away. If you need to come back to the video, watch it. But I think you're hopefully seeing that this is a simple process and not shying away from it. Take it on.